Hello everyone. Today I'll present my this practice, which name is Shift Register, and we are going to implement on the FPGA 10 DA10 Lite board using VHDL in Quartus Prime Lite. So this practice we are going to design, simulate, and implement an 8-bit bidirectional shift register using the 15 MHz clock of the FPGA. These circuits shift a single bit across the LED, moving from right to left and then back again, creating a continuous motion effect. All of the design was made in VHDL, simulated in Questa, Intel FPGA, and implemented on the FPGA. So first we created a new project in Quartus Prime Lite, selecting the Max 10 device family, which corresponds to the DA10 Lite board, and inside the project we wrote the main VHDL file called shiftreg.vhd, which contains the clock divided and the shift register logic. The clock divided reduces the 15 MHz input clock frequency to a much slower one, around 48 Hz, so that the lead LED movement is visible to the human eye. To do this, I use a 26-bit counter, and bit number 20 was selected as the divided clock input. Then, in the shift register process, the LED are controlled by an 8-bit signal. This signal starts with value 00000001 and shifts to the left every time the divided clock has rising edge. When it reaches the end, automatically changes the direction and starts shifting to the right, creating a back and front animation. The direction is controlled by a signal called FWD, which switches between left and right movement. So after completing the design, we created a test bench file to simulate the clock and verify the behavior. The test bench generates a 15 MHz clock by toggling the signal every 10 nanoseconds, and we observed how the bits shift properly during simulation. The Questa Intel FPGA simulation confirmed that the LED partner moves correctly, and the divided clock produces the expected lower frequency. So once the simulation results were correct, we used the plane planner to assign physical FPGA pins. Each output bit of the register was connected to one LED on the DA10 Lite board. The reset button was mapped to pin setting, and the 15 MHz clock input to the pin 11. P11. After compiling the design and programming the FPGA, we can see the LEDs lighting up one by one from right to left and reversing direction from left to right. When we press the reset switch, LEDs turn off and the sequence restarted from the beginning. So let's go to the FPGA board and see how it works. So here you can see the LED switching from left to right and right to left, and this LED 9 is the clock of the input. And as you can see, if we switch this switch on, it stops, and if we turn it off, it starts again. So that's this practice for the FPGA board, and see you in the next one.